Hello everybody, we're back. PC did a cheeky blue screen of death, so that's fun. Apologies. Try and get my camera back up and running. Have camera error as well, which is lovely. We are back, we're back. I'm just trying to sort the cameras out. One, two, 1, 2. Yes, very frustrating. Apologies, guys. We had a blue screen of death on the PC, so it restarted and it causes the stream to start again from fresh. Very frustrating. Sorry. Right. So yes, we have RCA connected and we have the amp hooked up. So we're just going to see whether it plays into the sub. I'm sure it probably will. Turn the gain down a little bit. There we go. Very nice. You love to see it. Yep, so that is a fully functional Powerus PW15000. Love to see it. Very little work needed. Very confused as to what the previous technician was having a problem with, but I'll be interested to know. Let's power this off and let's look at something else. Sam, you got a fish tank? No, I don't have a fish tank. Interesting question. Oh, might be nice if I like fish, if you like fish. I don't really have a strong opinion either way, really. I mean, I just feel like it'd be a headache to maintain, so I'm not that keen. That was a very nice, easy repair. Yeah, I was expecting that to be an absolute headache, but yeah, nice and easy. Very strange, but there we are. The screws for this are downstairs, so I'm just going to pop that behind me with some of the tape that it came with on it to keep that back in place. And now we can have a little chat and you can watch me fit 64 IRFB 4127s to a bunch of base face 8Ks and a Taramps Smart 5. Did you buy it at a good price? I think so. I can't actually remember how much I paid for it. I don't want to touch my phone because it's tethering and this is how the stream's working. I think maybe I paid like... Ooh. Maybe like around the £200 mark shipped from Europe. I think it was somewhere around that maybe. And now I can probably sell it for somewhere in the £700 or £800 region. So a nice little profit there. But I will want to do some endurance testing on it though before I sell it, because obviously I don't know the history of it. I don't know why that happened in the first place, etc. So we'll see. Yeah. Right. RFB 4127s. Let's go. I want to do the Smart 5 first. Where's that? Where have I put the Smart 5? Here it is. So I believe this Smart 5 is ready for output FETs. We have confirmed the drive circuit appears to be fully functional and operational, so let's go straight ahead with dropping some FETs in. Love this focus. Very, very good focusing job, guys. The stream cam does not do very good at focusing for some reason. It didn't used to be this bad. Like when I used it as the hat cam, it used to do a pretty good job of focusing, right? So I don't know why all of a sudden it's doing a really bad job. Is it trying to focus on something else in the shot? I don't know. Configure video, camera control, focus. Yep. There we go, that's better. These streams don't really do so well these days. Kind of sad. Used to be able to cook up at least 80-90 viewers constantly for the stream. Currently struggling to pass sort of 50. I think these streams are kind of past it a little bit. I've kind of done everything now. That's why I don't stream so much these days. I've kind of shown most things. It's all a bit samey, isn't it, after a while? The Smart 5s absolutely love blowing the traces open to the FETs on the board, so we're going to have to do a lot of trace repair. Let's get this one back up and running once we've fitted the FETs. Steve says, I love your streams. Thank you very much, Steve. I appreciate that. What was the Smart 5K in for? Reason for blowing? Well, the client doesn't know, but this is one of the very early Smart 5s, and when they first started building the Smart 5s, they didn't actually put any insulation under the output inductors to the main board. So I am willing to bet that there is a short between the output inductor and the board on this side specifically, which had the most damage. So what I'm going to do is actually fit the FETs, and after I've fitted the FETs, I'm going to desolder both of these inductors and actually place some paper or card or something between the inductor and the main board. Because even if it isn't shorting at the moment, it almost certainly will in the future. So we're either going to do a repair or a preventative repair there to stop that from happening, because it kills these. And in the new ones, in the more recent Smart 5s, probably after I mentioned it on stream actually, or on the video that I did of the Smart 5 when it first came out, I mentioned it. And since then they've been putting some kind of board, empty PCB board stuff between the inductor and the main board to prevent that from shorting. So does anybody want to buy a Powerus PW15000 1-ohm version? Does anybody want to buy a Teramps HD15K 1-ohm version? Does anybody want to buy a 2-ohm version? I have both working. Does anybody want to buy a Mercedes Vito bass van? So my bass van is currently up for sale. I am selling it. It is listed up for sale now. Surprisingly, I haven't had much interest yet. I thought I was going to get a lot of interest. I've had people asking me for years, "Oh Sam, when are you going to sell the van? When you sell it, let me know. Really interested. Oh, I'll buy that from you." But I haven't had anyone come through yet with any interest. So this is so many MOSFETs. How much for the van, and is the equipment included? Yes. So I'm selling the van as a fully kitted out, ready to go bass van. It's got it's obviously got the hardwood acoustics built in it. So I asked Henry, I said, how much would it cost now if someone brought you a empty Mercedes Vito to have this exact build done? He said it would cost 10 grand in just labour, plus materials, plus all the wood and all of the other materials that would be needed to make that build happen. So you're probably looking at like at least 11 grand for that build to happen now. Just the build. So the vehicle is a Mercedes Vito. It's an 06, so it's Euro 3, so it's going to run forever. Awesome engines. It's got 46,000 miles on it. It's an 06 plate with 46,000 miles. It's brand new. It's not even been broken in yet. It is no rust. The paintwork, a little bit sketchy here and there because it is an old van. Obviously, it's had that 20 years of sun, so it's got a bit of clear coat peel, but generally it's very tidy. For a 20-year-old van, it is as close to brand new as you're going to get, with a full hard acoustics build in it and all the equipment. It's got 4 Stinger SP2150s, it's got a Teramps HD10K, it's got 3 Genesis profile amplifiers, it's got DDA series front end, it's got a DSP, it's got 4 10s behind the seats, it's got a pair of base face Team Red 15s, it's got an inverter, it's got the Pioneer high-end head unit, it's got all the kit. It is sick. What am I asking? I'm asking for 10 grand, which is more than the van's worth, like without the build in it for sure. But there is nothing close to this that exists in the UK at the moment at all. Both in the ridiculous low mileage Vito, which is like a unicorn. The closest one that I found for sale that had under 60,000 miles was a 2016, which is like a way crappier engine, all this AdBlue Euro crap. So if you want proper decent diesel engine, then this is what you're looking at. And it's a fully kitted out demo van with the build in it. So yes, that's what I'm asking, but obviously it's going to go to somebody that really wants exactly what it is. An audio enthusiast, a bass head that has a bit of money, that is looking to save a lot of money, not having a build done when it's already done. Yes, I do get friends and family asking me to repair random stuff like air fryers and all sorts, yes, and I do. So I'm just tacking the gate leg in from the top of the board, because the gate leg doesn't have much thermal mass, so it just kind of solders very quickly, just to hold the MOSFET in, so I can then flip it over, go to the underside of the board and solder it in properly from the other side, just so that the FETs don't fall out when I flip it upside down. Happy birthday, Sam, from Christopher. Thank you very much, my friend. I appreciate that. Very kind of you. So yeah, these Smart 5s, when they go down, they're pretty catastrophic. There was a lot to fix on this. Lots of drive circuit, lots of resistors, lots of diodes. They get hit pretty bad when they fail. Maybe some brand new videos are in order. Well, yeah, I'll do some videos with the base face 15Ks. Sorry, base face Team Reds before I sell it, perhaps. Yep, Tarrant's Smart 5. I suspect it has shorted inductors to the PCB. That's usually what happens in these early ones. Ah, who's seen the new kicker? L7XS, whatever it is. Man, that thing looks absolutely insane. I would love to give a try of some of those. They look absolutely awesome. I'm sure the price is going to be monstrous. Thank you, Latvian, for the €2. It's your birthday. Yes, it is. Thank you very much for the cheeky little donation there. I appreciate you, my friend. Thanks for dropping in. Hope you're doing well. And that's my first super chat ever. No way! Well, I appreciate that, man. Thank you very much. I hope it wasn't too painful. Thank you very much indeed. I'll have a sip of Vimto to that. Simon, if you're going to buy a few, oh man, they're going to be so expensive. Like, yeah, they're cool. They're going to make lots of views on, I'll tell you what, if you did some like videos on your TikTok, you know, like how you do your videos. If you do some videos of the new kickers, they're going to pop off. Then videos are going to pop. So maybe that's something to get excited about. The new kicker XS18 looks nutty. 4-inch voice coil, gets its own motor and the 15 under 3-inch coils. Yeah, that looks mad. How often do you repair kicker brand amps? Basically never. Very rarely, and usually it's old school ones that have been abused. Nobody over here buys brand new kicker amps, because, well, there isn't a kicker dealer in the UK for a start, so somebody would have to be importing them, which is very expensive and they make no sense. Everyone over here in the UK is buying Chinese Brazilian clones like Edge, Vibe, Bassface, that kind of thing. That's what everyone's using because they are UK brands and they're very, very cheap. I don't mind it. Like, they're not the best amps by any stretch of the imagination, but they are so cheap for the power that it's really difficult to recommend anything else. 5,000 watts RMS genuinely makes 5k for £250 brand new with a warranty. That's cheaper than the used price of like an old Korean 5k, and it's more efficient. Like, you know, they're not the best amps and they're clones of the Sound Distros, but you can't really argue with the price. You can't really say, oh yeah, you're better off spending 6 times the price on something older, less efficient, maybe more reliable though, but you know, you could pay for 4 repairs and still be cheaper than buying a replacement, like an old Korean, a brand new one or something. Kicker doesn't offer schematics for repair. I never use schematics. Like, very, very rarely, if I'm very stuck, or if I have components that aren't obvious that I need to replace that I don't know what they are, but literally never use schematics. I'm so sorry about this crappy camera. It's so bad. I will hook up my capture card, I promise, for future streams. Just repairing the traces now on the top of the board here. These Tarrant Smart 5s do not actually have particularly thick traces on the board here. So when you get a high current failure event in the output section like this, the traces act like a fuse. I actually wonder whether they would be more efficient and do more power if the traces were a bit thicker. Because you know, this doesn't happen to many amps where you get traces fuse open like this, so it must mean that the traces here are thinner than some other options on the market. Rockford only makes schematic available for the products that are end of life. You can't get them for any of their newer amps. Interesting. I feel like Rockford though, I feel like a lot of their newer amps are kind of based on their older amps anyway, so you can kind of get an idea of what you need to do if you have a schematic for some of their older stuff. Okay, I think that's all of the traces on the top of the board for this side repaired. I'm going to trim that. I don't really like how that looks. So that's that trace. That one's alright. I'm just going to go over really closely and carefully now. Just check all the traces are intact. Yep. And this side actually survived. It wasn't part of the failure, but it's got new FETs anyway. But that one shouldn't have any fused traces. Let's check on the bottom of the board. That all looks alright as well. Excellent stuff. So now we're going to go ahead and power this up. I do have the amp in a sort of low voltage safety service mode. And on the Smart 5s, it's really simple to get this into like low voltage safe power up mode. All you got to do is focus your camera first so that people can see what you're doing. Focus. There we go. It's a bit better. All you got to do is remove a little transistor here. There's a little transistor that connects the CSD pins to the MCU via a few transistors and resistors. Just remove this transistor right here, and yeah, the output drivers will start Class D oscillating from the moment that you apply the remote, pretty much. So that's what I'm just going to check right now. Make sure that we have pulses. I don't think with these ones though, I don't think that Class D switching is particularly reliable. Like, it doesn't look an amazing shape, but the pulses are at least there. Another thing you can do, which is really useful, is you can remove the 10 ohm resistors that feed VCC to the power supply drivers here, and that prevents the power supply MOSFETs from oscillating, therefore it doesn't build rail voltage, which is very useful. So that allows us to check the output section with a low voltage rail. We can inject 12 volts into the rail and check for Class D switching. So, remote. The remote on these amps goes all the way over on the speaker terminal, which is very different to what you'll be used to. There we go. And I think we're going to want a load across the speaker terminals, which is often the case when doing low voltage rail power-ups. And we're also probably going to want to inject 12 volts onto the rail, but I'll do that in a minute. I think that's going to be here. Yeah. So we'll do that in a minute, but we'll just check that the drivers and everything are still working. So let's go ahead and reject low frequency on the scope. Turn the power supply on here. Let's just keep it low. Let's go up to 12 volts, and let's just make sure that we have gate drive over here. Yep, there you go. Got some gate drive. But we won't have any drive on the low side drain because we don't have any rail voltage at all. We just have like 0 volts. So in order to get some voltage on there, we're just going to connect 12 volts to the positive rail. And that will give us a rail voltage of 12 volts. So we're just going to shove our 12 volt wire just in the back of this rectifier, which will do it on the other side. That will give us 12 volts worth of rail. That just confirms that everything is A-OK. Excellent. So now we have 12 volts worth of rail on the high side. So if I do Class D switching over here, yes, we have Class D switching. Fantastic. Quite noisy, but that's fine. So what I wanted to do, the reason I wanted to do this is I wanted to check to see whether anything happened to the Class D waveform when I wiggled the inductors, because I wanted to see whether this failure was caused by a shorting inductor to the main board. No, seems to be okie dokie. Nothing happening there when I wiggle the inductor. Now, there's nothing underneath the inductor here to isolate it from the main board, so I'm going to put some paper or some insulation between the inductor and the main board, because this is what causes these amps to fail quite a lot. So I will do that, but this little test here has confirmed that this amp is going to work, and if I injected RCA right now, we'd get audio output. So all I've got to do now to reverse the kind of low rail voltage service mode that we've got this in is turn the hot air station on. We've just got to put the resistors back for the power supply drivers and refit this little transistor. Let's have a piece of chocolate, shall we? Let's try not to grab the chocolate with my thermal paste hands. Happy birthday, Sam. Thank you very much. Hope you're doing well. If you do, the chocolate will melt nicely. Very true. But I will also get cancer, which we don't want. Happy birthday, Sam. The clue was in the title. Thank you very much, buddy. Appreciate that. That's alright. The title was quite small anyway. There we go. So, removing our 12-volt wire from the in the rectifier there, we should now be able to do a full rail voltage power up test. Yep, everything's back together and ready to go. So I'm going to probe the low side drain on the side over here that failed. Wow, a 200 NOx from Ollie48. Thank you very much, my friend. That's extremely generous of you. That is quite a decent amount of money. Appreciate that, man. Thank you very much for the generosity. Hope you're doing well. If there's anything I can help you with, any questions you want answering, just give me a shout, man. I really appreciate that. That's very kind. $200 NOx, that's decent, that is. And I know it because it's an orange one, so that's decent. Thank you very much. Okay, let's hit it with some voltage and do a full power test. Knock it down to about 9.7, and the remote here. I'm just going to put my, like, I'm not expecting this to blow up, but I'm just going to put my fingers in my ears anyway, just, you know, just in case. You never know what's going to happen. Ta-da! There we go, lovely jubbly. 3.4 amps of idle current draw. A little bit of movement there actually on the duty cycle. Not the stablest of waveforms, but it is working. I will plug a speaker in shortly to double check everything's alright. I do want to use my thermal imaging camera to check all of the heat on the MOSFETs, but alas I cannot because I'm using my phone as tethering for the stream, so I can't do that. Norwegian kroners, I believe, NOK, NOKs. I'm just going to go through each of the gates and check that the gate waveforms look identical between these FETs. Very important thing to do. I should have done this when it was in service mode actually. Right, number 1, number 2, number 3, number 4, excellent. And let's check here. 1, 2, 3, 4. Yep, looking perfect. Power off, and just quickly check for heat on these. Just, they should all be warming evenly. Yes. There is some warmth coming from them. There's a little bit of cross conduction with these, but that's fine. Cool, nice. That's a fix. Yes, I do have a thermal camera. Thermal imaging camera is here, but it's a USB-C one, and I do have a Wi-Fi adapter in here, but it's been temperamental and it's caused the stream to drop out. So I'm currently connected the PC to my phone to tether the Wi-Fi from. So I don't have I can't plug this in to do a check, but yes, I do have a thermal cam. Can you see it going? I wish you could. I can try and unplug my phone, and hopefully my Wi-Fi adapter is working. So if the stream disappears, then you know why. So I apologise if the stream disappears. Ready? 3, 2. Okay, the Wi-Fi dongle did work. So it did work, and it is working. So yes, you can see the thermal camera now. Okay. Thermal camera. Here we go, 10 miles down. Oh, I've got 3% battery as well. Lovely. Okay, so we are looking at the board over here. Yes, so generally a bit of heat over here, that's fine, and we don't want any heat on the MOSFETs. Yeah, they're just kind of 32 degrees, that's fine. If we put the macro lens on, then we can go up real close to the driver. That's good. 41 degrees on that resistor, that's fine. So yeah, everything is looking cushy. This is genuinely the best thermal camera that I've ever seen. Absolutely incredible little device, this. Has the PC not been charging it? Yes, but no. It's trying to charge it, but there's not enough current from the USB port for it to work and for it to charge. So it was still discharging, even though it was on charge. Thermal camera is one of the essential tools for amplifier repair, in my opinion. If somebody wants to get into doing electronics repair, the absolutely essential tools, you can't get around it. The essential tools are oscilloscope. Absolutely essential. You can't do electronics repair without an oscilloscope. A very cheap basic multimeter. Don't spend a lot of money on a multimeter. Just the most basic cheap rubbish. Maybe not the cheapest rubbish, but something cheap. Just literally you're going to be using it for continuity mode and diode mode, and that's pretty much it. Yeah, cheap multimeter, decent oscilloscope, but don't overspend, get a used one, and a decent thermal camera ideally one of these ones, Thermal Master. I've got it linked in the description of this stream. Best thermal camera that I've ever used. Absolutely insane little thing. So yes, thermal camera, cheap multimeter, oscilloscope, and obviously your hot air station, your soldering iron, decent flux. But yeah, once you've got that stuff, you're pretty much ready to go. This little thermal camera has genuinely saved my ass on so many repairs. I repaired a T-Amp 1500, which was my own amp, PA amplifier, that I was gifted in broken condition, and I never would have found the fault with the class GH drive circuit without a thermal camera to compare the two channels. It's a 2-channel amplifier, to compare what resistors were getting warm on the working channel and where the heat, because basically a thermal camera doesn't just show you heat. What a thermal camera shows you is it shows you the path of current, okay? So when you're talking about repairing electronics, okay, there are two components to electronics: voltage and current. Voltage you read with your oscilloscope. Yeah, you see DC, or you see waveforms, or you see fluctuating voltages. So the oscilloscope are your eyes into the voltage, the pressure. The thermal camera is your eyes into the current. An oscilloscope can't measure current, it can't read current, it can only measure the voltage in two different places, and you can try and calculate current, but it's complicated. Thermal imaging camera shows you how much current is well, not exactly, but it shows you different levels of current passing through different components. So if you've got a board that's not working, that's doing something weird, or that's behaving in a strange way, then you can look at the board layout and you can say, right, you know, this resistor is in line with the supply voltage, so it should be getting warm at least. There should be some heat coming from it. You know, you can look at drive ICs, like any IC is going to emit some heat if it's working, right? So you can use your thermal imaging camera, you can see where is current going, what components are warming up because they're being run, because actually there is electricity passing through them. And if you see a really cold area, if you see resistors that really should be getting warm because they should be doing work, they should be dropping voltage, they should be in line with something, and they're not, then you're like, right, that area isn't working. There's no voltage there for some reason. There's something not happy about that. Yeah, this saved my ass on the GH repair for sure. Paid for itself just in that one repair, and has been invaluable, honestly. Like without a thermal imaging camera now, I'd be kind of lost in a lot of aspects with repair. I wouldn't trust a lot of the work I did was okay without going over it with a thermal imaging camera to check everything is like within spec heat wise. Yeah, it's so good. There is a link for this one in my stream description if you want to check it out. Yeah, they are. If you're doing repair, even if you're just doing it as a hobby, you will be able to fix things using the thermal imaging camera, so it will pay for itself in the stuff that you fix that you're able to then use or sell. Alright, well, we've done Sundown NS2, we've done Powerus PW15000, we've done Taramps Smart 5. I think we're done now for repairs, but we can have a little chat for a bit before I head off, if there's anything you want to talk about. Any questions or curiosities that you might have, we can have a little chat. Sinewave, save me too. Without that imaging camera, I wouldn't know for sure that it was a dead driver chip when I fixed the amplifier. Yeah, exactly. Exactly, yeah, it sorted you out with that repair for sure. The great thing about the USB thermal cameras is you're only paying for the thermal imaging hardware. All the processing is done by either your phone or your PC, which saves a huge amount of cost. Like if this was an all-in-one unit that had all this, the screen and the processing in it, obviously it'd be a lot more expensive. So everyone has a phone. You know, everyone's got a phone, so you can just get this adapter, plug it in, and then all of a sudden you've got a thermal camera that performs like a £2,000-3,000 thermal camera used, you know, that you would buy not even that long ago, 5-8 years ago. You know, £2,000, £3,000 thermal imaging camera would perform like how this does, and I think they're like £250 or something crazy like that. It's wild. How often do you get fully working amps sent in? Right now I have an internship in basic repair shop. Recently multiple things were brought in, all worked perfectly. Yes, I do get that. Actually, surprisingly often, yeah. Surprisingly often. I recently had a pair of Boston amplifiers sent to me that were working fine, for example. So, yeah, I mean, I'd say maybe like 2 or 3 a week, perhaps. Maybe a bit less. Maybe 1 a week average or something like that. What's your view on the Steg amps looking at the K2.04? Not sure. We don't have Steg in the UK, so I haven't seen enough of them to be able to give you an educated opinion, I'm afraid. But I've seen a couple of Steg amps, and from what I have seen, they seem pretty nice. What I would say though is, it sounds like you're running a sub, and you've said you're going to run it bridged. For subwoofer application, the only thing that matters is dynamic headroom. Don't buy a subwoofer amplifier because of its amplifier class topology. Don't buy a Class AB subwoofer amplifier. Don't buy an SQ amp for your subwoofer. Buy an amplifier that is designed well, that has loads more power than you need, that will last the time that you're going to be using it for, and that is cheap, like, for the power. Don't go spending $1,000 on something that's like 800 watts, Class AB, fucking, you know, high SQ brand, whatever, blah blah blah. For subwoofer application, buy something that is tried and tested as a well-designed circuit with tons of power, modern and efficient. For example, Taramps Big Boss 3, Smart 3, Powerus PW15000, yeah, something like that. Class D, high power density, more power than you need, efficient, and very, very cheap for the power, because that's what's going to make your sub sound good, is having that headroom there for the dynamics of your subwoofer channel, the subwoofer track, to be able to produce a waveform that has high transients without going anywhere near clipping, and that can run for extended periods of time, cranked up pretty high without overheating. That is what I always recommend to people, because for subwoofer application, the fine details of the amp in terms of its like performance on paper, signal to noise ratio, THD, it doesn't matter. It all goes out the window as soon as you're running a sub. The manufacturers even list their dynamic capability. How can you tell? What I mean by dynamic headroom is not the dynamic power of the amplifier specifically. I mean having enough power in the amplifier so that you can, like, let's say you've got a 500 watt RMS subwoofer. Okay, that means that subwoofer should, in theory, be able to handle 500 watts of average power over the course of a piece of music. So over the course of a piece of music, 500 watts RMS average across that track. That means that there will be transient spikes on the kick drums in excess of 1500 watts on that one transient kick drum, you know, that repeats perhaps. But also there are gaps in between those transients, and also the sine waves, the fundamentals might be like 300-400 watts, especially with the impedance rise. So what you need an amplifier that can give you enough headroom before clipping to average out at 500 watts across the entire track. That's what you want. That's what's going to sound good. It's all well and good having an amp that can make 500 watts RMS with your 500 watt RMS sub. You play a sine wave at 500 watts and the amp and sub both reach their limits at a similar time. But when you're talking about playing music and you've got the varying frequencies and you've got higher frequencies that aren't yielding as much impedance rise, that there's a lot more power being sent to the sub. For that tiny transient, that 500 watt sub can handle like double, triple, quadruple the power rating, and you want an amplifier there that can give it that, for it to sound great and dynamic and clean while it's doing that, so it's nowhere near clip point. Yeah, basically oversizing the amp gives you dynamic headroom, because it gives you headroom in the amplifier for dynamics, rather than just playing a constant sine wave at the amplifier's clip point. Did everybody see my latest purchase? I bought an Earthquake Slaps 15, a passive radiator, 15-inch passive radiator. It's a V1. I don't think it's adjustable. It's got a 13 Hertz FS, and it generally tunes to 20 Hertz, 21 Hertz. Very excited to play with that. The ideal pairing would be like a long stroke 10-inch, or like a nice home theater 12-inch sub or something. Yeah, the FS of a passive radiator doesn't mean that's the frequency that it's going to tune to, because as soon as you put the passive radiator in an enclosure, you also have the air spring that then completely throws out the window the resonant frequency. But yeah, it generally tunes the enclosure to about 20 Hertz. They're for home theater application. Those Earthquake Slaps, like, they are meant to tune really low, and I think it'd be great for home theater. It'd be so nice. For home theatre in the lounge at the moment, I have a pair of Pioneer TSW 2504 SPL. They are like miniature Pioneer Premier 3004s. They're the 10-inch version, and they're so cool. They're very, very cool subs. Probably the worst decision to, like, they're not going to be the best sounding, or they're not going to play up the frequency range like a Dayton home theatre sub would, for example, but to have a couple of Pioneers like that in the lounge and just see them there, freaking awesome, and they sound great. Does it even function on low power? Yeah, a passive radiator is a port. It's a mechanical port. So ports function at low power? Yeah, of course they do. Yeah, a passive radiator is a mechanical port. You trade off passive radiator versus port. Port obviously gives you, the benefit of a port is it gives you basically unlimited displacement until it starts choking. Unlimited displacement where it takes over from the driver to give you a massive bump in output at its frequency that it resonates at. But the downside of a port is that it requires a specific, a minimum box volume and a port size, area and length to function at a specific tuning frequency. And once you start going really small, like 6.5 inches and below, you really struggle to tune the thing low enough. You either have to make the box too big, in which case you unload the driver, or it's too small and you get port noise, etc. So the benefit of a passive radiator is that you remove the enclosure volume requirements and the port size requirement, because it's a mechanical port. So you can make the enclosure very, very, very small, and you can achieve ridiculously low frequencies from very, very small drivers. However, the downside to the passive radiator is that the displacement that it can offer compared to a port is limited, because it has literal mechanical limits. It can't move beyond a certain point, whereas a port can throw immense amounts of air out and in because it doesn't have mechanical constraints. So that's the trade-off. Ports for getting loud if you have the space required and you're tuning to a frequency that is sensible for the driver size, etc., and the enclosure size that you're doing. But if you're doing extreme low frequencies, and not even extreme low frequencies like you think, trying to get 35 Hertz out of a 3-inch driver, that is extreme, because the frequency compared to the driver size is extreme. So trying to tune an enclosure for a 3-inch driver to 35 Hertz is very difficult. It's going to sound like ass if it's ported. That's why everyone uses passive radiators for Bluetooth speakers, for hi-fis, anything that is small like that, portable, small, but also wanting to hit low frequencies. passive radiators are used, because it just makes sense. They're just infinitely better. But yes, in the same way that if you wanted to build a car audio setup and you wanted to play 15-20 hertz from the boot without going for a crazy wall build, passive radiators would actually probably be better than using ports in that instance. But yeah, I think, guys, it is 11 PM in the UK here, and I have a 7-month-old now, so mornings are like 6 AM starts. So I'm not really looking to do a super late night. So I think we're going to leave it there. It's been a great stream. Thank you very much for joining me on my birthday. It was actually my birthday on the 7th, but I was busy on the 7th, so it's a bit of a delayed birthday stream. But it is still a stream for my birthday. So thank you very much for joining. I massively appreciate everyone that dropped in donations. Very kind of you. Thank you very much for that. And we'll see you in the next stream. Not sure what it will be, but it'll be something interesting. So yeah, have a great evening. Catch you